In this video, we'll be talking about the first of the methods that take into account all the information in the table, not just the top row as the plurality method did. So this method will be called the Borda count method, and named after the Frenchman Borda. So how this method works is, first we need to assign points values to first, second, third, fourth, fifth, however many places we have. So since there's 5 candidates in this round, 5 different places, 5 different rankings, we're going to give first place 5 points, second place will get 4, third place gets 3, fourth place gets 2, and fifth place gets 1 point. So what does that mean exactly? So let's say we get a finished ballot from one of these 5 people. So these 5 people have voted E as their first place candidate, B as a second, D third, C fourth, and A fifth. That means that E, being the first place candidate, will receive 5 points, 5 Borda points, from each of these 5 candidates for a total of 25 Borda points. But where else is E getting points from? Each of these 21 people actually put him last. So he's only getting 1 point from each of these 21 people for a total of 21 points only. But also we have these 2 people right here who put him second to last. So he's getting 2 points from each of these 2 people for a total of 4 points. And that's how we calculate the Borda totals. And the winner, whoever has the most Borda points, will be the Borda candidate or the Borda winner, the winner of the selection. So let's go ahead and just calculate them. So we'll start with A. So A gets how many Borda points? So he is listed first. He's the first place candidate in all these 21 people. So he's getting 21, and he's getting 5 points for being the first place candidate from each person. Now he's listed last on all of these lists for each of these 27 people. So he's only getting 1 point from each of the 27 people. And that gives us a total of 132 Borda points for A. Now what about B, the person who we probably think is going to win based on the results of the last video? Well, B is getting 4 points from each of these 21 people. He's getting 5 points from each of these 20 people. He's getting 4 points from each of these 5 people. He's getting 3 points from each of these 2 people. So that gives us a grand total of how many Borda points? That gives us a grand total of 210 Borda points. So we already see this big discrepancy. He's already getting so many more Borda points than A. So he's going to be probably a likely winner. But let's go ahead and calculate C, and then we'll give the numbers for D and E. So let's look at C. C is getting how many? So C is he's getting 3 points from each of these 21 people. He's getting 2 points from each of these 20 people. He's getting 2 points from each of these 5 people. And lastly, he's getting 4 points from each of these 2 people. And if we add all these up, he's getting a total of 121 Borda points. And now D and E we can calculate the same exact way. And D, if we calculate that, he's going to get 127 Borda points. And then E, if we calculate that, he's going to get 130 Borda points. So there's a few interesting things to note here. So the winner of the election is going to be, let's put in red all of their Borda totals so we don't get mixed up. So we obviously see that 210 is the highest number. So B is going to be the Borda candidate or the winner of this election under the Borda method. But also some interesting things to note here. A was the clear winner under the plurality method if we only saw the top line. But A has 132 Borda points. So he is coming in second in this election, but barely. E is just 2 less than him, and D is not much. He's only a few less than him as well. So C is also pretty close. So we see that A is not exactly the strongest candidate. He may be the second strongest under the Borda method, but he's still pretty close to all these runner-ups down here. So we see that this method is a more holistic method. We take into account much more information, and we make a much better picture. But again, no method is without its shortcomings. So let's talk about some of the shortcomings of the Borda method, just as we did about the plurality method. So here's another table. This is a different election altogether. In this election, there's only 4 candidates, A, B, C, and D. So we've asked all the voters, all these 13 voters, to list their preferences first, second, third, and fourth. So here's the table. So now let's talk about who is the majority candidate here. So that means who, if any candidates, has more than 50% of the vote. Well, and we're talking about only first place votes here. So A gets 7 votes, B gets 3, and C gets 3 as well. So since 7 is more than half of 13, so half of 13 is 6.5, and 7 is more than that, A is the majority candidate. And this is under the majority principle, which we talked about is a stronger version of the plurality method. So A is the majority candidate. What about the Condorcet candidate? So I've saved the time and I've written out all the pairs. So if we match AB head-to-head, AC head-to-head, AD, BC, BD head-to-head, these are the point totals. And the winner of the first three is A, the winner of the second two is B, and the winner of the last one is C. So what does the Condorcet principle says? The Condorcet principle says that the winner of an election should be the person who, if you go head-to-head against every other candidate, you win every single time. So who is the Condorcet candidate here? It's going to be A again, because A versus B, winner is A. A versus C, winner is A. A versus D, winner is A. So A is the winner against every other candidate. So he is the Condorcet candidate as well. But who is the Borda candidate? So I've written out the totals. I've done the addition multiplication here. A gets 34 Borda points. B gets 39 Borda points. C gets 35. D gets 22. So A falls in third place, surprisingly, here. He's behind B, who is the Borda candidate, and C, who is second place. But A, just one less than that, he's third place. The only person he beats is D. So how can this happen? How can the Borda method be such a great method if it disagrees with the majority principle and the Condorcet principle? So we think that it's probably a bad method. Well, we have to be careful. It's not a bad method. And voting experts, a lot of voting theory experts have talked about the Borda method, and they agree, and based on statistical evidence, that it is a strong method and it works. It's very effective usually. So to convince you of this, because you're probably thinking now, you're probably a little hesitant to accept this method, there's two major things we can talk about. So, but the first thing we talk about is that violating the majority principle is rare. So in this example, I kind of set myself up for failure. I kind of set this up to fail on purpose so we could see that the majority principle can be violated. And you kind of see that here because A is given the last set here with these 6 people, and he's given the first place here with these 7 people, and 7 is more than 6. So it's kind of been, I kind of rigged this in a way. I kind of put the numbers so that we could learn a little bit of lesson here. So, but in general, in real elections, in real world elections, violating the majority principle is rare. It's not going to happen as much as we see in this example right here. And the second thing is that violating M, so I'm going to put M for majority principle. So violating the majority principle or criterion leads to a violation of the Condorcet principle. So if you violate the majority principle, you automatically violate the Condorcet principle. And for a video on why this is true, click right here. It'll be a short video, and just convince yourself of this. So why is this important? This means that if you violate the majority principle, you violate the Condorcet principle. So it's not like you're violating 2 at the same time here. It's that you violated the majority and therefore you violated the Condorcet. So it's not like you violated 2 principles independently. It's more like violating 1 principle, which logically leads to a violation of the other principle. So this method is very powerful, and just keep these 2 things in mind. This is rare. It usually won't be violated. I just set this up so we could learn that it's possible to happen. So again, Borda count method, first method we talked about where you take everything into account, and it is a very elegant, beautiful, simple method to find a better winner than the plurality method.